Alright, now we're on to lesson 8.2, which is ellipses. In this problem, we're going to find its vertices, foci, eccentricity, and what I'm going to do is move the 124 over to the right side.
Oh, I broke it.
So that's going to make it negative 124. Alright, now to solve this problem, we're going to have to complete the square twice. So, for the x side, you're going to have 4x squared minus 32x plus, plus your spot for your blank, because that's where you're actually going to put the square you complete. Continuing on, plus y squared, running out of room, plus 16y, and again, your blank spot for your completed square. Okay, now back over here to this side. We're going to take the 4 out, so that leaves you with x squared minus 8x. And just to make it easier, we'll complete the square right here. So half of that would be 4 squared is 16. And then over to the y, plus, don't even have to take anything out here. Just go y squared. And then half of 16 is 4. So it's plus 16y. And squared that is 6, or it's 8, my bad. Plus that is 64. Alright, now onto the other side here, you have your negative 124, which you're going to add both of your completed squares to. And since you have 16 on that side times the 4, you get 64. And then again, 64 because that is the y squared.
Now we're going to zoom out here, look at it. So on this side we're going to just factor these guys, and we're going to combine like terms over here. So this ends up being 4x minus 4 squared. This is going to be plus y plus 8 squared equals, then we combine like terms, we have that ends up being, it's negative 124 plus 128, so that's just going to be 4. So when we zoom out and look at this, or look at the whole thing, we'll notice that we need to make this equal 1. So to do that, we're going to divide everything by 4. So that divided by 4, divided by 4, divided by 4. So when we do that, this is going to end up being x minus 4 squared plus y plus 8 squared over 4 equals 1. This is going to be over 1. Now, with ellipses, we always want the biggest number on the bottom to come first, because that's the a squared. So I'm just going to rewrite this like this, so it looks exactly like it is written on our blue sheet. Do that, and we know that that this ellipse is, because the biggest number is under the 4, the biggest number is under the y. It's going to be an ellipse on the vertical axis, so it's going to be a tall ellipse instead of a fat ellipse. So now we just pull out the different elements of this that are on our blue sheet. First, it's not in the problem, but I think it makes it easier if you write it down, so you can kind of look at it. We can find the center. It's right here in broad daylight. It's just going to be 4 and negative 8, because it's just h and k. We do that a lot, h and k. So this is just according to your blue sheet now. Now let's find some other things that are going to be helpful to us as we find the last few elements here. A is this here, or this is a squared. So if we take the square root of that, we'll end up with a equals 2. And then this is b squared, so b equals 1. Now this is really important to remember because it's the only one like this. The Pythagorean relation for the ellipses is a squared equals b squared plus c squared. All the other ones, the Pythagorean theorem, all that's c squared equals a squared plus b squared. This is just the oddball out. Forgot to put parentheses on there. So just remember that the ellipses are the ones where, it's the one that's different from all the rest. So we plug in a squared is 4 equals b squared plus c squared, and we subtract over 3 equals c squared. C equals the square root of 3. So I'll put that over here. Now remember we said this was an ellipse on the vertical axis, so that means that A is what is the distance for the major axis, and that's going to change the y value. So we're just going to add 2 and to the y value of the center. It's the center plus 2 and the center minus 2. Those are going to be our vertices. So that looks like vertices. If we just draw a quick picture here, our center is going to be there because it's vertical. This is going to be our A distance to our vertices. Then we'll have a, ellipse like that. Just a little visual for you there. So vertices are going to be 4. The x values are going to stay the same. 4, negative 10, and 4, negative 6. So those are our 2 vertices. Next, we have the foci, and they're going to be on that same axis. So they're still right along in here. They're just going to be between the center and the vertices. They're going to be the same thing, only we're going to add and subtract c instead of a. So it's going to be, but the same. The x value is going to stay the same because it's still on that same axis. Negative 8 plus or minus the square root of 3. That's the foci. So if we go back up to the top here, we have successfully found the vertices and the foci. The eccentricity, we still need to find that. And I don't know, asymptotes, ellipses don't have asymptotes. Those are hyperbolas, so I don't know why we wrote that in there in the beginning, but we won't need to find those. So all we have is the eccentricity. And this is also on your blue sheet, but I'll write it here. Eccentricity equals c over a. So we have those. We already have those figured out. C and A right up there. So all we have to do is write E equals square root of 3 and over 2. And because the square root's on top and not on bottom, that's our final answer. So we have the vertices, the foci, and the eccentricity. There we go. that is pretty much the gist of lesson 8.2.